All right. If you are joining my live now, we'll be looking at shape of molecule and hybridization. Shape of molecule and hybridization. We'll be looking at what? Shape of molecule and what? Hybridization. When we look at shape of molecule, is a type of when an atom has what, two atoms joined together, two or more atoms joined together, one must be a central atom. Do you get that? And this molecule, of course, you know what a molecule is. We are going to look at the various shape of molecules. We are going to look at hybridization of this molecule, and we will all equally join, bond, and go together. Now we have different types of shape of molecule. One, we have what we call, I'm going to give you according to how the atoms are formed. Remember, if atoms are two, we have mostly they are always two. When we have, like, let's just say something like CO2, the atom here is what? The atom here, we have two atoms, we have two elements. Now, two elements, oxygen here has what? Two atoms. Do you get that? We have the one of three, like now here NH3. Do you get that? We have the one of four, like CH4. Do you get that? We have the one of five, like PCl5. Are you following? We have the one of six, like SF6. So we are going to look at the atoms here. Like this one has what? Two atoms. This one has what? Three atoms. This one four atoms. This one five atoms. How are they called? These are the various shapes. This is what we're going to look at, and equally look at the type of hybridization being possessed by these various shape of atoms. Now we are going to proceed. I don't know whether you are hearing me. Now we are going to proceed. If a shape, the first shape is called a linear shape. Linear shape. The second shape is called, or we have what we call bent shape. We are going to look at according to how they are. If two elements combine to have one, what, two atoms, the way it is, then that is how we are going to look at it there. Okay, we have bent shape, or you call it what? V shape. V shape. Three, we have what we call trigonal. Trigonal planar. Four, we have trigonal pyramidal. Trigonal pyramidal. Five, pyramidal. Are you following? Six, we are going to look at tetrahedral. Tetrahedral. We have octahedral, and so on and so forth. So we are going to look at the various shape. We look at the type of hybridization they have on angle. So this video is very, very inspiring. You are using just one video to learn a lot of things. Do you get that? All right. Now let's look at linear shape. If a shape is linear, how is it? if you have only two elements, one of the element having two atoms, it will be either linear shape or bent shape. I repeat myself. If you have two elements, of course, all of them here have what, two elements attached together. If one of the element has two atoms, like in the case of this one, has what, two atoms, it means that it will either be what, linear shape or what, bent shape. For instance, we have CO2, we have H2O, we have BlC2. Have you seen? This one now, they have what? Two elements, but one having what? Two atoms. We have the central atom, like in the case of this beryllium chloride here. Beryllium is a central atom. Here, oxygen is a central atom. Carbon here is what? A central atom. Now, let us look at their shape, how they look like. All right, so just follow me as we go. Like, for instance, now, carbon here, look at. Carbon is. Now, look at how it is there. Remember, carbon has 4 valence electrons. If you draw the shape of, look at, the first shell carry 2, second shell will be what? Look at, carbon is atomic number what? Atomic number 6. So 1, 2, 3, 4, 5, 6. The valence shell now, how many electrons are in the shell in carbon is? This second shell has what? 1, 2, 3, 4. So we have 1, 2, 3, 4. Do you get that? Oxygen, I'm explaining this one. The rest I will just take the examples here. We'll use this example to explain the rest. I might not explain detail like this. Now, oxygen has how many valence electron? Oxygen has what? 6 valence electron. We have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This 6 valence electron. Now, oxygen need 2 to complete. This one need 2 to complete. Carbon, on the other hand, needs what? Needs 4 to complete. So, carbon will now carry these 2 now and bond with this one to be what? 1, 2 here. Have you seen? Now carry this 2 here and bond with this one. So, 2 of them are now what? Are now complete. Are you seeing? 2 of them are now complete. So now, because of that, they will have a shape like this. Because of that, they will now. Let's clean this one. This is how the shape of this carbon 4 oxide is. This type of shape is called, because it is straight line. Angle at the straight line is called what? Angle 180. A straight line angle, and that straight line is what we call what? Linear shape. Do you get that? So oxide is what? Is linear, and because of it is linear, the bond angle will what? 180 degrees. Are you following? This is the bond angle. Now let's look at the hybridization. I hope you are following. Are you following? All right, beautiful. This is how it is. This is the bond angle. Angle at a straight line is 180. Is it not so? Now let's look at the hybridization. I say I'm going to bring these 3 things together. In the case of hybridization, remember, it is the blending of 2 similar orbitals to form what? A new hybridized orbital. Now, when an atom or when a molecule has 2 bonds connected to it, we have what we call 2 bonds, we have 3 bonds, we have 4 bonds, we have 5 bonds. Let's just stop from there. Now, when it has 2 bonds, it will be what? It will be sp. When it has 2, let's just say group. Let me put this one group. I will explain what group is. You can say bond, all right? When it has 3 group, we have what? sp2. When it has 3 group, we have what? Sorry, when it has 4 group, we have what? sp3. When it has group, we have what? sp3d. When it has 6 group, we have what? sp3d2. These are the various types of hybridization we are going to look at. I don't know whether someone is following me. Okay, you are following. Beautiful, beautiful. All right, I'm sorry. Now, when they group, I will explain what this group means. This group can be said to be what? Bond. Can be said to be bond. All right. I have told you the first, we are explaining this one, linear shape. If you see something a straight line, it is what? It is linear. And a straight line will have a bond angle and a bond angle of what? 180 degrees. Are you following? Now, what type of hybridization? Now, for you to know the type of hybridization, you have to count the bond that connect the central atoms together. A bond that connect the central atoms together, that is where to know the hybridization. How many bonds connect this one? You are not looking at single bond or group. Look at 1, 2. We have 2 bonds connecting this one together. That is, this one is treated as one. All right. Whether it is lone pair electron, you count it as well. So because it is one, look at 1 and 1, 2. 1, 2. You get that? So because there are 2 here, there are 2 group here. You say is what? One will be for X, and the other one will be what? For P. That is why you call it what? SP hybridization. Are you following? SP hybridization. Therefore, carbon 4 oxide will be what? SP what? SP hybridization. If there are 2 bonds, I will give you another example of that. You say what? Okay, I'm sorry. I never knew that it's blocking. Can you see now? Can you see now? Can you see clearly now? It is clear now, right? All right. Now, beautiful. Now, this kind of hybridization that has sp hybridization can also be found in member of organic compound called alkyne. Alkyne. Look at alkyne here. Alkyne is, for instance, now we look at ethyne. Ethyne. We have H here. We have what? H here. Now you are looking at the central atom. Hybridization always occur at the central atom. If you look at it, the central atom is carbon. We have a bond connecting this one, connecting this one. So you are looking at the central atom. What connects the central atom? That is where we look at hybridization. Now this one, now you are going to look at the central atom. It is either carbon of this one is the central atom, or carbon of this one is the central atom. Do you understand? So if you look at the carbon of this one as the central atom, the bond connecting this hydrogen to this carbon is what? We have one here. The bond connecting this carbon atom to this one, we have what? We have one here. Therefore, there are 2. So 2 will be what? sp hybridization. So hybridization in alkyne, this is alkyne. Call it what? Ethyne. Hybridization in ethyne is what? sp hybridization. Someone following? Are you following? Are you following? You can double tap on the screen to give me like. You can like the class. Beautiful. Can we proceed? Can we proceed? Can we proceed? Now we have a lot of things to treat on. Now let's go to the second one. The second one is what? Bell shape or V shape. I told you that bell shape or V shape. Okay, we have looked at this one. If you look at this beryllium too, look at this beryllium chloride. Let's look at what will happen here. Let's look at what happened in beryllium. Look at beryllium. Beryllium has what? Sorry, this is beryllium. Beryllium has what? Hydrogen, helium, lithium, beryllium. Beryllium has what? 4 number of what? Proton. That is atomic number what? 4. Now that 4, 2 will be out and left with what? 2. So we have what? Only 2 what? 2 electrons in the shell. If you also look at hydrogen, helium, lithium, beryllium. So beryllium only has 2 valence electrons. These are the 2 valence electrons. Look at chlorine here. There are 2 chlorine. So you have 1 chlorine here. You have 1 chlorine here. Now this chlorine needs 1 electron to complete because chlorine has how many valence electron? Chlorine has 7 valence electron. Needs 1 to complete. So we have 1 here, 2, 3, 4, 5, 6, and 1 and 7. This one 1, 2, 3, 4, 5, 6, and what? 7. So this one now they will now pair. This one now transfer this one to this one, so that will now form what? A complete bond. This one is the same thing. Complete what? Complete bond. So all of them are in the same altitude. So do what? Is a straight line. Have you seen? It therefore means that beryllium chloride also has what? A linear shape, and the bond angle will be what? 180. The hybridization will be what? Will be sp hybridization. Look at the bond connecting this one, the bond connecting this one. So there are 2 bonds, so it will be what? Sp hybridization. Therefore, we have beryllium chloride. So the example of sp hybridization or shape, we have what? Carbon 4 oxide and beryllium chloride. Are you following? The board is far. I'm just doing so that you can capture the whole area. Are you following? I will try and write in the other page so that you will see. Okay, you are following. Beautiful. Can we proceed? Can we proceed? Now, we now proceed to the next one. You understand linear shape. Linear must be what? Must be 2 elements attaching together. One of the elements must have 2 atoms. You can see here, carbon and oxygen attach themselves. Oxygen has 2 atoms. If it is more than 2 atoms, it will not be what? It will not be linear. Now let's proceed. Bend shape or V shape. Bend shape or V shape. Bend shape or V shape. We are going to look at the one that is bend shape and V shape. Now, in the case of bend shape and V shape, what happened? Let's look at the case of water. H2O. Hydrogen and oxygen. The central atom will be what? Central atom. So the central atom here will be what? Will be oxygen. Are you following? Now we have what? We have water this side, hydrogen this side, we have hydrogen this side. Now, how many electron has hydrogen? Hydrogen is number 1, so it has what? 1 valence electron. We'll put the electron here. How many electron has another hydrogen? This one will put what? 1 electron here. Oxygen here, I'm just taking it in. We have a way you can just look at the compound and you know the type of hybridization, increase the occur, the shape of the molecule, and the bond angle. But I'm just doing it a bit by bit so that you understand. This is basic chemistry. Basic chemistry. Now look at the valence electron of oxygen. I told you oxygen has what? 6 valence electron. So we have uh 1 2, let's just say 1 2 3 4 5 6. Are you following? 6 valence electron. Now what will happen is that this one there will pair with this one to be complete. Are you following? This one will pair with this one to be what? To be complete. So there will be 2 left. There will be 2 electron that is left. We have 1 here and we have. Do you get that? Now because of this lone pair electron that is here, I don't know whether you are following. Are you? Oh, I'm sorry. Bad. For now, we have 2 lone pair electron that is here will now cause the shape to what? To bend. So this shape is now, because it's bending like this, it's like V. All right. So we have what? 10.4 104.5. The bond angle will be what? 10. So hybridization. Hybridization. Are you following? Hybridization. The hybridization. Look at 1 2 3 4. 1 sp3 hybridization. So the shape of water is bent, or you call it V shape, and it has hybridization of what? sp3 hybridization. Do you understand? Are you following? Can we proceed to the next one? Can we proceed to the next one? Can we proceed? I repeat, look at water. The valence of oxygen are what? Are 6. Hydrogen has only 1. Let me explain it again. Network was a little bit glitch. Now look at central atom with what? Oxygen. Here, 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 here. This one has 1 valence electron. This one has what? 1 valence electron. Oxygen on the other hand has what? 6 valence electron. We have 1 2 3 4 5 6. This one now will now be one left to be paired. We have 1. Look at, we count this one as a pair electron. Pair electron. Now because of these 2 that are left now, will now cause the shape to what? To pair. There will be electron repulsion. According to Vaspar theory, there will be electron repulsion. Now cause this one not to bear. Look at it now. We call it what? Bend shape, or you call it V. If you look at how it is here, you will know that it is V. If you turn it upside down now, look at now. Let me turn it upside down. Networkers. So I'm sorry, network has been disturbing. So that is what hybridization in water. So water has what? sp3 hybridization. All right, sp3 hybridization. sp3 hybridization. Now let's look at this one. The next one is what? Trigonal planner. Trigonal planner. Trigonal planner. In the case of trigonal planner, this trigonal planner is mostly three atoms of one. There must be, of course, look at this one now. This one will be what? Trigonal planner. You can see another example where we have beryllium trifluoride. There are three what? Three atoms of fluorine, three atoms of what? So anyone that has three atoms like this will fall under this trigonal. All right. Anyone that has this like this will fall under what? Trigonal. Now, I hope you are following. Now, let's look at the example of trigonal planner. When you have beryllium fluoride, beryllium what? Fluoride, trifluoride. Sorry, I'm calling it beryllium boron trifluoride. Now, this boron has how many valence electrons? Hydrogen, helium, lithium, beryllium, boron. So has what? 3 valence electron. So valence electron will be 1, 2. All right. Now fluorine, on the other hand, fluorine has 7 valence electron. It means that it needs 1 to complete its shell. Fluorine needs 1 to complete its shell. Are you following? Fluorine needs 1 to complete the shell. And since it needs 1 and there are 3 fluorine, so one will be here, one will be here, and what? One will be here. And this one needs 1 to complete. So I what? 1. Look at how it is here. Here, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. 1 is left to complete because everyone is trying to be like take those noble gases. 1 is left to complete. So because he has 1 here, this is a 1. So now we now carry this one and join here, carry this one over and join here. You can see that there is no 1 that is left to be unpaired. No lone pair electron that is here. So this one is what? Is complete. And the shape of this one is what we call trigonal planner. Trigonal planner. Are you following? Trigonal planner. Trigonal planner in the sense that this is like a triangle. Look at. You know that a triangle is like this. You can say like this. You can turn the shape like this. This is a triangle. Is it not so? So the shape of this one is trigonal planner. Do you understand? Now, because of that, there is no lone pair electron here. And because of that, it is what? Planner. Trigonal planner. Are you following? Now, what is the hybridization? Can you guess? What should be the hybridization? What should be the hybridization? Hybridization of this one, it will be what? Look at. We have 1 here, 2 here, 3 here. So 3 will be what? 3 is hybridization. sp2 what? sp2 hybridization. Are you following? And the bond angle of this one will be what? The bond angle will be 119 or 120 degrees. That is the bond angle. Angle will be 119 and what? Or 120. There are some books that you see 120. There are some books you see what? 119. So you are still correct. So a typical example of trigonal planner is found in what? In boron trifluoride. Are you following? trigonal planar. We will now proceed to trigonal pyramidal. Remember, I told you that this one, these two has two elements. All of them has 2 elements, but this one has what? One of the elements will have what? 2 atoms. So we have the case of CO2, we have the case of H2O, we have the case of BCl2. That is for what? For this one. This one and this one. These are then the one that has 3, like this one now and this one. We are now going to look at the shape of this ammonia and see how it is, whether it will be trigonal planar or trigonal pyramidal. I told you planar because of what? This one, the central atom does not have a lone pair electron. Does not have what? Electron here, just like in the case of water. This one does not have. That is why it is called what? Planar. Now we are going to look at the one of ammonia, whether it will have something like, if it has something like this, similar to that, it will fall under what? Trigonal planar. But if you have a lone pair electron here, it will fall under what? Pyramidal. It is like a pyramid. From India, beautiful. Okay, you are from India. That is wonderful. Thank you for watching. Thank you for watching. Now we are now going to look at the one of what? The one of water. Now in the case of water now, we are looking at what? Sorry, we are looking at what? Ammonia. Ammonia is NH3. Look at N here has how many valence? Surrounded by what? 3 atoms of what? Of hydrogen. We have hydrogen here, we have hydrogen here, and we have what? Hydrogen here. Ammonia has how many valence electrons? 5 valence electrons. So we have what? 1, 2, 3, 4, 5. Hydrogen has 1 valence electron. So we have 1 valence electron, 1 valence electron, 1 valence electron. So they will pair. This one will cancel a pair. So this one is now complete. Alright? Form something like this. This one will complete. So we can form something. And this one will pair with this one, form something like this. So there's only a lone pair of electrons that will not be left. Are you following? Beautiful. How are you? Rajik, Benedict, trigonal pyramidal, beautiful. Now, why it is like this now? Because I told you that any one that has a lone pair electron, the one that is not paired, will cause what we call electron repulsion. You call this shape now, this hydrogen now, to what? To bend, to repel themselves. Now what will happen? You see something like this. You're going to see something like this. You're going to see something like this. NH. This what? This is a shape. Because of this lump is here will cause this shape to what? To be like this. And that is what we call pyramid. This is like a pyramid. No pyramid is like this. Do you understand? A pyramid is like this. So the shape of this ammonia is what? Trigonal pyramidal. It's like a triangle, but now in a pyramid form. Unlike this one. This one is not like a pyramid. Do you understand? So now, since it is like that, what type of hybridization is this? Okay, let's look at the bond angle. The bond angle of this one will be what? 107 degrees. The bond angle will be what? 107 degrees. And what is the type of hybridization? Who can guess? What's the type of hybridization? The hybridization will be what? Hybridization in this one will be what? How many bonds are there? We have 1, 2, 3, and 4. 4 is what? Look at 4 bond is what? Is what? Is sp3 hybridization. sp3 hybridization. Both trigonal, pyramidal, and tetrahedral will have what? sp3 hybridization. Example: methane. Look at now. How many bonds surround the central atom? We have 1, 2, 3, 4. 4 is what? Look at 4 is what? sp3. So methane has what? All alkane has what? sp3 hybridization. All alkene in organic compound has what? sp2 hybridization. For instance, now we have C double bond. Now this one, now look at, you are looking at the central atom. If you can decide to pick this one, you can decide to pick. If you pick this one, how many bond? 1, 2, 3. 3 is what? Look at sp2 hybridization. So this one is what? 18. Is that understood? Is that understood? Beautiful, beautiful, beautiful. So now the trigonal by pyramidal in this phosphorus pentachloride. Phosphorus pentachloride. Now what happened in this one? The type of hybridization here will be what? What type of hybridization is here? Look at. Let me give you a hybridization here so that I will widely leave. Now, if you look at this one, we have here phosphorus has how many valence electrons? Phosphorus belongs to the same group with what? With nitrogen. Are you following? Phosphorus belongs to the same group with what? With nitrogen. Phosphorus belongs to the same group with what? With nitrogen. Now, valence electron. 1, 2, 3, 4, 5. And we have how many chlorine atoms? There are 5 chlorine atoms. We have 1 here. We have 2 here. We have what? 3 here. We have what? 4 here. We have what? 5 here. So this one will come here. This one will come here. This bond will come here. This one now will come here, and this one will come here. So this is how the shape of what? The shape of this phosphorus pentachloride will be. So how many bonds total? We have 1, 2, 3, 4, 5. 5 bonds will be what? sp3d hybridization. So hybridization here is what? sp3d hybridization, and it will be what? Trigonal bipyramidal. Trigonal bipyramidal. So that is where we're going to end today. See you in our next class. Bye. Do you enjoy the class? Do you enjoy the class? All right. See you next time. Bye.